Good morning. I'm Bill Nordhaus. I'm here at Yale University, and I'm saying hello across the waters, across the Pacific to Japan. I have been asked by Max Tavoni if I would say a few words on this occasion. I've learned that I've been awarded the Lifetime Distinction Award of the Society of the Integrated Assessment Modeling Consortium. Assuming that actually has taken place, I am extremely honored at that award. I'd like to take a few minutes in this to reflect on the history of integrated assessment modeling. It goes back a long way, and this is a wonderful representation, and I send my greetings to the founders, Naki Nakachevich, with whom I've worked a long time, and one of our books that we've worked on together is shown in this pile here. John Wyatt, who also I've been a long-term colleague with, going back to the Energy Modeling Forum, and then before that, the Modeling Resource Group. And a person I know only less, not so well, is Makiko Kainumo, who is the third co-founder of the consortium. So to you and the people who are joining you in Japan, and the people who couldn't make it, I'd say hello. So as I was thinking about this, what I might say this morning, actually, I picked up the New York Times, and there was a lead front page story saying that people were extremely surprised, and disappointed, of course, but surprised that the emissions trajectories of countries were not going to meet the 2-degree goal, and even though we have the Paris Accord that was recently signed. Well, I think if you're in the audience there, if you're an integrated assessment modeler in the field of climate change, at least, you were hardly surprised. This has been known since really the day one after the Paris Accord, has been confirmed by many modeling studies since that time. So the only surprise is that people weren't aware of this and didn't take it into account. But that's just a long line of work that has gone on in the integrated assessment modeling community, and very fine work it is. I'd say a word about the deep history of integrated assessment modeling. If you go back and look at the citations and the searches and the Google word search, the three early places where integrated assessment modeling, actual words occur, were, I think, first in agriculture, where it was a combination of weather events and agricultural productivity. Then the next was the acid rain program, NAPAP, in the United States in the roughly 1980s. And then, of course, finally in energy modeling, particularly climate change modeling, starting at various points. So if I were to go back to the genealogy, not the citations, it would pretty clearly start with Koopmans and Kantarovich, the discoverers of linear programming. They had a very integrated assessment point of view. Kantarovich, perhaps the most ambitious, and his work was trying to understand how to put pricing, how to use pricing in a centrally planned economy, and the idea of using shadow prices as a way of finding the appropriate market prices, even though it was a centrally planned economy, was a revolutionary idea, and of course leads right into the work that many of us do in trying to determine the shadow prices for carbon dioxide emissions, or what's now called the social cost of carbon. So that was a very integrated approach. Charlie Koopmans also, in his work on tankers and the routing of tankers, was an early use of optimization techniques that are now widely used. In the area that many of us do, which is energy and climate change, I started my own work in the 1970s. I found, actually, as I was just thumbing through, I found the computer principle. You can't really see it, but it goes on a few pages of an energy model, which was part of the earliest carbon dioxide model. It's written in Fortran and is pretty pretty close to machine language. It's not really machine language, but it's much more complex than the software that we write now. The earliest model that I worked on was at YASA with Naki Nakachevich, who was a colleague there, Alan Mann as well, who was a great integrated assessment modeler. And that is, here's a copy of the YASA working paper from 1975, and it was actually just republished in the June 2019 edition of the American Economic Review. And as I worked on that, it was surprising. There were almost no changes I had to make in that. I mean, there were some things I might have. It was clearly a fossil from an earlier age, but the fossil didn't need too much. Actually, I didn't have any cleaning at all. So you can see some of the first work attempts at integrated assessment modeling from 1975. An interesting part of that was actually that it used the 2-degree target as a device for closing the model, an integrated assessment model, even though at that time I thought it was very unsatisfactory. We then move on to move forward. I'll say something about I asked the question, why didn't we have integrated assessment modeling before World War II or before the 1950s? And the answer is we didn't have the technical capabilities of doing it, because it would require data, it would require software, and it would require computational facilities, computational abilities that was beyond us in the pre-computer age. I'd just say one other thing, going back to the early phases. I think actually, if I were to nominate the first integrated assessment model of a kind we know today, it would be the early econometric models, macroeconomic models, which were integrated in the sense they integrated different parts of the economy. They weren't integrated across different disciplines. Well, unless you consider statistics, econometrics, economics, data science, estimation, and so on, different disciplines, but they didn't include, as we do today, say the physical sciences or atmospheric chemistry, but they were integrated in the sense of using a multi-equation point approach. It's interesting, Koopmans, who was an inventor both of econometrics and of linear programming, or now is mathematical programming, that even though one of the branches of his discovery, which was econometrics, has been widely used in many areas, it's the other branch of his discovery, which was linear programming, and then which is the core of many of our algorithms in mathematical optimization today. It's interesting that our discipline is almost 100% following that second route of mathematical programming based on following up the linear programming. There's virtually no econometric integrated assessment models. There are virtually none. But they all come sort of two branches of the genealogy, if you like, the genealogical tree, that the integrated assessment modeling took the programming one rather than the econometric one. Well, I think we could celebrate the achievements of integrated assessment modeling. Unlike many areas of society, it has shown a structure, how to think about climate change, what kinds of policies are effective, what kinds of policies are ineffective, and this central organizing core, which is the social cost of carbon, or the shadow price on carbon dioxide emissions in our technical language, has played a big role. And it wouldn't be possible to even think in that way without the kind of integrated assessment modeling that we do now. Well, I wish you a good meeting. I'm sorry I can't join you, but I say hello to my friends in Japan today, and I wish you good luck and have a good meeting. And goodbye.